All right. Hi, everyone, and welcome back. And thanks for joining. Thank you to all our moderators for working behind the scenes to support this live event. And I'm super excited to have my esteemed colleague, Daniel Mauser, as a co-presenter today. Daniel has done some amazing work with DNS scenarios, and I've personally learned a lot from him. So thank you, Daniel. So today we're going to talk about DNS options in Azure. So let's face it, right? When there are outages, you've probably heard the phrase, it's the network. Well, when it's not the network, it's DNS, right? So DNS misconfigurations and failures like networking and BGP can cripple the network at a global scale. So it's important to set up our DNS infrastructure right? Um, so DNS traditionally fell under the umbrella of system administrator. But cloud blends all the silos, and it's important for networking teams and cloud architects to have a deeper understanding of DNS. So for the purpose of this session, I'm going to assume basic DNS knowledge. However, I want to take a few minutes to go over some concepts. I've listed a few concepts over here. Of course, just to level set the terminology and what you will be seeing on my screen for the next half hour or so. Of course, it's a layer in Draw.io, so if you can always hide it depending on the knowledge of your audience. If you're presenting this session, you can hide that layer as well. So let's look at the concept. Imagine that this is you sitting at your home, at your office, at Starbucks, and you're issuing this query or this, you're browsing this website called red.nihaliniyogi.org. You may remember that from our previous load balancing session. And what happens when you do that, right? So simplistically put, you just magically get an IP address back, right? And you can browse the website. But there is a lot that happens behind the scenes. So let's look at all of the different concepts. The first one is that the first thing the client will do is consult the DNS server, the local internal DNS server. Sometimes it's also a caching only or also a DHCP server for that internal network. That DNS server will do a global forwarder or a conditional forwarder to your ISP's DNS server. And your ISP's DNS server will do a recursive lookup. And by recursive lookup, it would first consult the root name servers, then the .org, and then the authoritative name servers for nihaliniyogi.org, right? And so that introduces the fourth concept, which is the root name servers. Now, root names, if you want to see how this whole orange bits work, the recursive lookup, you can issue this command called dig with a trace. All of these commands are in the FAQ, so if you want to play with it or you want to check it out, be sure to look at the FAQ document, which is also in your invite. And then you have this fifth concept, which is the concept of authoritative name servers, right? So authoritative name servers are in this case happen to be hosted in Azure. You still have to buy the domain and you have to still delegate. You still need a registrar and you need to delegate the domain to Azure. And we'll go into a lot of depth with that as well. And then we look at the sixth concept, which is the CNAME and A record. So when you did that dig command, you got the CNAME, which is, if you remember from last session, it was the app gateway, and then the A record, which is finally the IP. From a client perspective, it just sees this pink arrows, which is a query and a response. And it doesn't know what is happening behind the scenes. And that introduces the last concept, which I will just mention it and then we'll do a deeper dive later, is the concept of split DNS. Split DNS means that depending on the source IP of the client, you'll get different responses. So if you're looking at it, you're internal to the network, you get a different IP, and if you're external to the network, you get a different IP. So then, now that we know these basic concepts, let's do a comparison with Azure. So in Azure, just like how you had this internal DNS server in your internal network, in Azure, when you spin up a VM, we have the concept of VNet level DNS server, this 168.63.129.16 IP. And we'll do a deeper dive in this in a little bit. But for comparison, when this VM issues a query to this VNet level DNS server, it will get the exact same public IP, just like how you got it on-prem or in your home network. Right? So conceptually, it is very similar how things work in Azure. So with that, I'm going to go to my first option. So by now you are familiar with this hub and spoke model. We've done it in a few sessions. All right, this architecture should look very, very familiar to you. And the way we will approach it, of course, is through draw IO layers. And we'll start with the most basic default configuration, and we'll progress through the layers and we understand the why behind the different use cases and why we would need the different options. So I will light up the first layer over here. In the first layer, I'm going to introduce three very important Azure services. The red box that you see is Azure's public DNS. The green box is Azure's private DNS zone. And then I will introduce a deeper concept of this VNet level DNS server configuration, which is that 168.63.129.16 IP that you see. So let's start with the Azure public DNS zone. So think of it as a name server infrastructure, right? It provides you these authoritative name servers for your domain. And of course, it's a platform as a service, so it's globally distributed and highly available. You could see that I have hosted my domain in Azure Public DNS. Of course, I still need to buy the domain and I still need a registrar, right? So once I have the registrar, I can delegate it to the Azure's Public DNS. So it's an authoritative DNS service. So let's look at the, and you can notice that I can manage the DNS, all of the DNS records in that public DNS zone. Now let's look at the private DNS zone. Private DNS zone is also a managed service, except that it ties into the Azure's VNet. In other words, you can resolve all the domains in a virtual network. Notice that I have given the same name to the public and the private DNS zones, and we'll tie that in a little bit. And after I cover this concept of, let me turn off this concepts layer. So let's look at this VNet level DNS configuration. If you go to an Azure VNet, and I've taken a screen capture so you know what that configuration is done, Azure has the option for you to do default DNS. And by default DNS, you get this VNet level VNet level DNS configuration out of the box. So let's look at this whole design from this VM's perspective, which is in a spoke VNet, and then we will look at it from this user out on the internet's perspective. Okay, so let's light up the next layer where I will do the query. And you can imagine, you can predict what the result is going to look like, right? So the same VM is going to look up red.nihalineogi.org, and this user is going to look up red.nihalineogi.org, which introduces the concept of split DNS. In other words, let's follow this trace from the perspective of this VM. This VM, when it is looking up red.nihalineogi.org, it got the private IP, the 1055.10.1. You will notice that I have put a TCP dump capture of the query and response for you to see that it was indeed that 168.63 IP that gave us the response. And then let's look at it from the perspective of this user. This user will, of course, query its local DNS, which will in turn do the recursive lookup. And that user got the public IP address. So that is the concept of split DNS, external user getting the external IP and internal user getting the internal IP for that same domain. Okay, and so what are some of the things to consider in this design is that often um, when you spin up this, when you create this private DNS zone, you have to create links. We refer to them as VNet links from that private DNS zone to the VNet in question. Okay, so let's say that you didn't configure or you missed configuring this VNet link. What will happen is it will fall back to the recursive mechanism, and you will get, even though you're internal, you will get the public IP. So be sure if something's not working to check out that you have correctly linked the VNets. Let's see. Um, as a best practice, it is always recommended that when you spin up VMs in Azure, not to change any OS level DNS configuration and use the VNet level DNS. This VNet level DNS is also a DHCP server behind the scenes. It has a lot more other functions, but it's a DNS and a DHCP server, highly redundant, and it's the same static IP that you cannot change, and it's the same IP in all of the regions. So with that, let's go to the next option. This option is what I refer to as Azure provided default DNS. So let's say that you just spun up a VM. You just spun up this VM in Azure. And then you ran this command ifconfig /all. I've highlighted the most important items. All of the yellow items really tell the story, right? So you will see that when we spun up this VM out of the box, no configuration, base configuration, it got this DNS suffix of internal.cloudapp.net. Of course, it got the IP address, it got the DHCP server, which is that 168 IP, and the DNS is also that exact same IP, right? So that confirms some of the things we looked at in the previous option. So what happens when you spin up this VM is both, so I have a few VMs in this subnet, and I have one VM in this subnet. I'm sorry, in that VNet. So what happens is all of these VMs will auto register to this Azure managed private DNS zone called internal.cloudapp.net. Same thing happens for this VNet. This VM will auto register to internal.cloudapp.net. So this is a very basic functionality, but it solves, let's look at what it does behind the scenes for us. So we'll look at a simple ping. If you issue sitting on VM1, if you issue a simple ping to VM2 just by the name, it will resolve it for you. So all of these auto registration features allows you to resolve all of the VMs that are in the same VNet. Okay, so same thing happens with on this side as well. Now, external resolution. So this is all internal resolution is working. Now let's look at how external resolution will work. So you are on this VM or on this VM and you did internal, so VM2, just like that. If you did a www.mit.edu, what will happen is, again, this VM will still consult this Azure DNS server, which behind the scene will do a recursive lookup, right? So it will hunt down the IP for you by doing that recursive lookup, and you will get just the final IP. So this model works, right? So you could do internal resolution for all of the VMs in that VNet, and you can also do external resolution. So what is the consideration for this design? So let's look at that. So in this design, what you cannot do is you cannot, this design is scoped to a virtual network. So you cannot resolve DNS names that are created in one virtual network from the other virtual networks. In other words, if I'm sitting on this spoke VM1 on spoke 1, I will not be able to resolve VM1, 2, and 3 that are in another VNet. All right, so that's the consideration for this design. It actually sets the stage for our next design and how we can address that. Of course, this is out of the box, no configuration from Azure, very simple POC, smaller environments. You can get started without doing a lot of work. So let's look at how, with this consideration in mind, let's look at option number 3. So let me turn off this layer. So I'm seeing a slight lag over there. Bear with me. All right, so in option 3, we're introducing the concept of Azure Private DNS Zone. Again, it's like you saw in the nihaliniyogi.org domain that we set up. It's a DNS service used to manage and resolve domain names within a virtual network, right? So let's see how we can have this centralized private DNS zone versus, if you remember before, we had this Azure managed internal .cloudapp.net, right? So that's the difference. So we bring the concept of Azure private DNS zone, which are managed by the user, and let's see how the registration of these VMs work. So there's a few things to observe over here, is that with this newly created private DNS zone, you can create a VNet link and specify that you want to register all of these VMs to this DNS zone. So let me zoom in a little bit so you can see that all of these VM, 1, 2, all 3 on the spoke 1 and spoke 2, both of them are all kind of registered to this central DNS zone. So with that, I can now resolve across VNet, and let's look at that. So if I'm sitting on this VM over here and I ping VM2, which is in the same VNet, we were able to resolve that before, and it still works. However, now I can also resolve spoke1-VM, which is on the other VNet from this same, from this VNet, from spoke to VNet, by the virtue of this VNet link, and both the VNets registering to the same private DNS zone. Important thing to call out over here, and there is a lot more to this, but if you look up, if you do a reverse DNS query of that IP address, for example, of VM2, for example, it would give you two records, because even though it registers to this nnlab.azure private DNS zone, it also still registers with the default internal .cloudapp.net. Okay. And one important thing to call out, and this is a trick question for our users who have seen other sessions, is that even though we can resolve the IP, even though this VM2, even though this VM can resolve the IP of the other spoke VM, it may not be able to talk to each other. So when you are working with DNS, remember that there is a DNS path and there is also the routing path, right? So if you remember from our previous session, you still have to enable the spoke-to-spoke connectivity, even though the DNS resolves correctly. So with this, it sets the stage, this private DNS zone set the stage for the concept of private link. I'm going to be covering private link in a lot of depth in a completely separate session, which I believe is 2 weeks from now. But for today's session, I'm going to introduce it briefly just to understand the concept of private link, and private DNS zones go hand in hand. So let's look at this, the concept of private link. Imagine this is a PaaS service, Azure PaaS service, could be a storage account or a SQL server. And the concept of private link is you do not want public access to any Azure PaaS service or that particular Azure PaaS service. So what you do is you project that PaaS service into a VNet and it gets an IP address. All right, it's not accessible from the public, but it gets an IP, a private public access IP. So then this on-prem user, of course, it has to have this express route or site-to-site connect private connectivity. This on-prem user can route to this IP. Okay, so 172.16 that we just projected in the VNet. And then the spoke can also route to it. The green lines are showing routing. However, the most important concept in this is the FQDN of the PaaS service. It is very important that you preserve the FQDN of the PaaS service, no matter if you access it from external user or the internal user. There is a lot to this. We will cover it in depth in the private link, but the reason behind that is that all PaaS services use a secure TLS method, and which requires that the SNI header is intact. And just for now, just keep that in mind, that preserving the FQDN is important. And so we need, every time you create a private endpoint, you need a private DNS zone. And that's what this private DNS zone is showing, that when you created that private endpoint, it created private link.blob.core.windows.net, and it gave you an A record for the storage account, which is a private IP. Okay, so let's review how that looks from this spoke VM's perspective first, and then we will look at it, how it looks externally when we have private. So we will look at it from this user who is outside of our network, both the perspective. So we'll take a closer look at this. Now that we have a private DNS zone set up, a VNet link, notice all these links are very important. If something is not working, be sure that you have linked these, the private DNS zone to the VNet in question. So now let's look at how that query would look like. Um, So I'm on the Spoke VM2, and I issue a dig command on and in storage.blob.core.windows.net, and I got the private IP. Of course, you can see with this TCP dump capture that it is indeed the Azure's DNS server that is returning first the CNAME record and then the A record of the private IP. Okay, so that's from inside the network. Now, what will happen if we were outside the network and we looked up? So there is a lot that happens. Let me just make sure I center this so you can see the full picture. So I am sitting outside. So this is the user sitting outside of our network. Again, like we saw in the concept, it would query its local DNS, which will recursively look up all of the root and the corresponding domain servers, and will give you the external IP of this storage account. The way it does it is, if you look at this output, and again these queries are in the FAQ document, that you get a threefold response. First, you get a CNAME, you get two CNAMEs, and then finally you get the A record. So I have listed it over here how the progression happens. But from this user's perspective, all he sees is the query and the response, and will get the public IP. So that's how the private endpoint works. Of course, even though you get the public IP, if you have disabled public access, you will still not able to get to the storage account, but the point is that DNS does resolve to the public IP when you are external to the network. Now, let's look at some of the considerations for this design, right? So couple considerations. One is that a lot of the VNet links, you have to manage and maintain this different VNet links when, as you spin up more VNets, you have to maintain these links. And the second consideration is that um, uh, from on-prem, you can still not, this your local DNS on-prem, can still not route to this 168 IP in Azure. So it will not be able to look up any of these private DNS zones that you have created in Azure. All right, so that sets the stage for, how do we achieve that on-prem resolution for all of the private DNS zones in Azure. I'm going to do a quick time check over here, and then I will turn it over to Daniel. Yes, a couple minutes. I'll just go over the fourth option real quick over here. So in this option, we introduced the concept of a centralized DNS server over here and a custom DNS server at the VNet level. So on the VNet level, you set up a custom DNS server, and in like a shared services VNet, you set up an IaaS VM. And let's look at the flow, how those would work. So from the Azure side, it would look fairly straightforward. It would go from the VM to the VNet level DNS server, and then to this DNS, and of course it will then resolve. It will then forward. It would have a global forwarder to Azure's DNS, which by the virtue of these two VNet links would resolve the two uh, Azure DNS zones for you, entries in the Azure DNS zones for you. And then the same thing will happen from on-prem, because now you have routing to the Azure DNS server. This VM will first consult its local DNS server, and which will in turn have a global forwarder to the Azure's um, to domains that are hosted in Azure. And because you now have the routing to it, you can then have another conditional forwarder to Azure's DNS. So you can follow the green lines for on-prem and the pink lines for how things will work within Azure. And then, of course, the external resolution continues to work. Azure's DNS will still do the recursive path, right? So this is a fairly complete option. If you look at this, this is a very common design that we see in Azure. Our customers use this. As you can see, you can do it from on-prem. If you see the full picture, you can do it within Azure, also from on-prem, and you have this centralized piece to it, so that you're not creating VNet links. The consideration for this design is that it's still an IaaS-based VM, so you have to maintain the VM patching and all of the bits that go with infrastructure as a service. And with that, I set the stage for Daniel over here, where we're going to go into, instead of an IaaS-based solution, we in Azure, we have something called Azure Private DNS Resolver. And what Azure Private DNS Resolver brings to the table, it is as a service. So remember how we spun up a VM? From a placement perspective, Private DNS Resolver works in the same way. It's also centralized. You spin up two subnets to deploy the private DNS resolver service. Again, it's fully managed. And Daniel's going to go into a lot of depth. I will show you two flows. One is from on-prem into Azure, same thing. You have two conditional forwarders on-prem for the two domains that are hosted in Azure, and then it will follow this red path. And then you have the outgoing flow, which is from Azure to on-prem, and I'll show that to you with the blue colored flows. The most important aspect of the outbound flow is the concept of forwarding rule set, and be sure to link that with your VNet. And same way it does the query, you can follow this blue path. It's important to have routing between the outbound endpoint and your headquarters. And that brings towards the end of my presentation. Daniel's going to cover this scenario at depth. And thank you again for joining.